channel, and Jamal will probably join in at some point here in the next few minutes, or they're waiting to catch the video. I'd just like to mention a few things before we get started. The program was mentioned on Carolina Now, and if you wish to watch the video, you can find the link on our Facebook page, and I'll also post it right here. So you can just go there. And the Kickstarter is up as well, so everyone please show their support. And if you can get your friends to donate even $1, it'd be great. Colette has got some code. It says, what does the fox say? And just like to remind everyone that we do need the code for the LED panels. And the instructor today is going to be Vaughan. Vaughan, are you ready for me to pass it off to you?
Yeah. Did you hear me?
Yeah, I'm passing it off.
Okay, yeah, just, okay, hold on. Okay, so we're going to just continue the way we were going last time on the rocket telemetry project. Like I said last time, if you got any questions, I want to try to keep that dashboard open, watch the chat, but you know, ping in there if you need to ask anything or if I can clear anything up. Okay, just a brief recap from last week. Start to finish project requires more than just programming skills. You have to be a jack of all trades a lot of times, be an engineer and a problem solver and a project manager and other soft skills. Programming's great, but you need to be able to think through the whole problem from start to finish and see where it can get you. Critical thinking and what we're doing now with the physical aspect, you also end up being an electrical engineer. With this project, the physical size of the rocket payload is almost the most limiting factor, and it's driving a lot of the decision making. And I brought up last time that there's all sorts of stuff out there on the internet and in forums and other places. There's just no need to reinvent the wheel. Go see what existing work is out there and make use of it. We're going to use the Arduino microcontroller for the main processor. We talked last time it's going to go as small as possible. I think I made a mistake last time. I called it a forget what I called it, but the smallest one I found that was usable is called the Pro Mini, and that was that super small little board. We'll see it in a minute. But still use the Uno, which is similar to the Diavolino. We did some soldering on for prototyping and testing because it's bigger. It's a lot easier to use, especially for us old guys who can't see small things anymore. But the sensors, BMP-085, will give us altitude and temperature. The ADXL345 is an accelerometer, and we're going to log the data on an SD card. And we talked about the possibility we could do a XB radio transmitter. Then everything's got to be soldered to a small board called a perf board that will fit in the payload section. Yeah. Okay. We're working on a prototype. Last week we wired the sensors up to a breadboard. The sensors needed 5-volt power and then power, the ground for the power loop. And then the actual communication is on what's called the I2C protocol, and that just requires 2 wires. So it's a a clock wire and a data wire. I2C is great because it just uses a couple of wires, and then you can also daisy chain the sensors. And let me jump over, and that's where we sort of were last week. And the I2C are these two wires here, and then you can see how easy it is just to jump from one sensor to another and daisy chain them. Each sensor gets its own ground and power. What wasn't hooked up last week is this SD card data logger. We'll talk about that in just a second. We talked briefly on fritzing. I could have just as easily done a pencil sketch. I like having a plan of attack, and fritzing gives me that plan of attack and it lets me go back, and when invariably something won't work, but I've got a roadmap in the fritzing thing, so I can go back and make sure I'm plugged into the right sockets and the pins are right and my wiring's right. Started the programming with the sample code that Adafruit provided, and it was just really easy to use that to make sure that the sensors were working and everything was coming together sort of step by step. We checked the code, the sample code for the copyright information, made sure it was okay for use in our project, and it is. I hate kind of dwelling on that, but it's a real important thing that you can get in a lot of trouble for, especially later in your educational career. If you steal some code that isn't yours, that's a big no-no. One sensor had the BSD license and one sensor had the Apache license, and both of those allow for sharing, and the only thing you really need to do is acknowledge where your code's coming from, and you'll see where I did that a little bit later. It's not real huge for this project because it's sort of just us, and I'm not building this to sell it or to make a profit off of it. But it's just good to know your habits are right and you're doing the right thing by other programmers. So where we left off is we have to wire up the data logger, the radio, test it, and start working on the software that will combine all the functions, and keep testing it, making sure everything still plays together nicely, and then start looking at going from our prototype setup to our finished setup. Two things I want to point out real quick, and it's applicable not just in software development, but in all sorts of problems. And I'm going to probably show my age by what I'm calling, and I'm not certain what all the hip kids today call this, but this was in the 1990s what we called it at school. But decomposition is when you take a problem and break it down into your smallest components, and you work on the small. It's building a house brick by brick. Don't worry that the house plans are so big and so large that you can't understand it. Just focus on working on the individual blocks of the code, and it'll all start coming together. And especially in software, you can. I've got programs at work that are, if I print them out, they're thousands of pages long, and if you look at it that way, it's just mind-boggling. But if you start really looking at it, you start seeing that, hey, this method right here, all it does is shift a decimal place and round the dollar value or something, and you start seeing that every huge program is just a collection of really small individual programs. So, and that applies to social studies projects or whatever else you're doing. Just focus on the smallest manageable thing. Don't get overwhelmed because you've got a massive term paper due, but you just work on the little steps, and the little steps will get you there. I see somebody's got cut out, but is everybody hearing me okay? Maybe. Yep, George does. Okay, good enough. The second thing is progressive elaboration. It goes hand in hand with the decomposition, and in programming, there's a buzzword right now that's agile development or incremental development. Progressive elaboration isn't everything that's in agile development, but the point is, like I was doing last week, you get your program up and running quickly. It doesn't have to be fleshed out. You just get something that works, and then you just keep adding to it, test it, add a little bit more to it, test it, and just focus on the incremental improvements. Don't worry about getting. I'm not worried about getting this whole rocket payload working the minute I plug it in and get all the modules talking and get it all working together all at once. If you do that, you'll hit a brick wall. But what you do is just get a little bit working, add a little bit more, get it working, and test. Always go back and test what you're doing. I think you'll see that brought out here in just a second. So we have to wire up the data logger. I got it from Adafruit. So like everything I do, I go and get the information about it, and they have this great tutorial. This is a part I bought. It uses a little micro SD card, and you can follow the tutorial. It goes all the way through. They have a section on how to wire it, and they even show you a little picture here. So somebody's already figured all this out, and like I say, I'm not reinventing the wheel. I just want to come and get something that's good to go and use it. So you can see I've followed their directions there. The other thing I did is I updated my fritzing sketch based on their directions. So I've got a roadmap to follow, and I didn't show you this last week, but what makes fritzing really neat for me is you can click on a pin, and you can see everything that pin connects to. So everything that's connected to the ground here on Arduino, you can see all the yellow lights up, and those are all my ground connections. So you can sort of see how the breadboard works. You can see I've got each board, each sensor part grounded, and it just, if you're troubleshooting, it makes it real easy to use. So it's a really neat thing, but like I say, it's not required. It's just something I like playing with. Ooh, if I can find my... that was Adafruit. I'll put that link on the Google group if anybody wants to look at it. But I skimmed through it, but the tutorial makes some real good points about that SD card. It's got to be formatted. It draws a lot of power. They say to keep the wires as short as possible. And they have other good tips and tricks in there. So somebody's already found those hang-ups with it, and I'm learning from them. So I'm basically just repeating here their directions, but it takes 4 wires for the data, and then the 2 more wires for the power and the ground. And you see those MISO and MOSI, all these abbreviations. I didn't know what it meant the first time I saw it, so I go Google it, and like MOSI is the master out, the slave in. So the Arduino is the master, the SD card is the slave, and the MISO is master in, slave out. So I'm not an electrical engineer by trade, but you have to sort of educate yourself as you go along. So I update my fritzing. And one thing as I'm doing all this, it crossed through my head. I've got all these Adafruit sensors now, and I had showed you last week that we're going to use a little red sensor. It's not made by Adafruit, so now I'm starting to worry. Well, that U sensor that's smaller and more compact, but that's great. That's what I need there. But will it work with the Adafruit sensor code, because I'm using all their stuff? Okay, so at this point I think I've got a working prototype as far as the hardware. I need to move to testing code and programming. And this is where I started. And like what I told you earlier is on the copyright stuff is I'm making sure in here I've got a little bit of just a brief sentence, but I'm giving credit where credit's due. Is some code is taken from portions of the Adafruit sample code for these two sensors. So I started with one sensor that we knew was running last week, and I started bringing in the other code, and I'll post this on the Google group. I tried to go through and comment for my own benefit and your benefit what every line is doing, or what groups of lines are doing, but I've combined the BMP and the ADXL. I'm loading the code for them. You have to give each one a unique ID. This is a function that will display some details about the sensor if you need to know more about it. Another function, especially for the ADXL, that this displays what data rate it's going at, and the data rate is directly affect how often you need to sense the acceleration. Because we're on a rocket, I want to sense very, very fast. My goal is to get at least 10 readings per second, if not 20 or 30 readings per second, because everything's going to change just super fast on a rocket. So I want to bump the data rate. This function just displays the data rate that it's set at, which is useful for troubleshooting. And another similar function displays the acceleration range. I believe I mentioned last week that we can probably expect a range over 10 Gs. I'm not certain what somebody on the group may know what a jet fighter pilot experience is, but I believe they start passing out somewhere around 10 Gs in combat aircraft and stuff. So we're planning on being able to measure up to 16 Gs, which I hope is enough. But after you get out of the different functions, you're in the setup. This runs once. I think it's been discussed a couple of times. It runs once at the very beginning of the program run. I get into it. I set up my serial communications because I'm testing it. I want it to display on my serial monitor. So I initialize the sensors. I check to make sure it's reading the sensor. So this is if there's not an accelerometer is basically what that's reading. It prints a warning message. Oops, no ADXL detected. Check your wiring. And then this is a neat little trick. It's a while loop. but it doesn't do anything. It's just while true. It'll always be true. So it basically doesn't it stops your code right dead in its tracks, and it won't do anything else. The same thing down here. If there's a BMP sensor, if there is one that doesn't do this, it just keeps on trucking through the code. But if it can't find one, it'll tell you it can't find one, and then it just stops. There's no use running any more of the code. Right? And I just talked about how we needed to select a range. So right here, I'm telling the accelerometer I want it to range to 16 Gs. If I said, well, I want to measure low G forces, I would just comment that back out and uncomment the 2G line, perhaps. But that's actually, I've got a little bit different code. I actually would need to set the range. I don't think I only need to change the one sentence. I didn't change the other sentences from the other lines from the sample code, but you can sort of see how that works. So I call the function display sensor details. So that will give me a printout of everything on the ADXL. Make sure I've got all my settings right. I'm displaying more information in the range. And then I'm out of my setup loop, or my setup function. Now I'm into the loop function, which runs over and over and is the main body of the program. This makes a new object, a sensor event object, so it's saying there's going to be a sensor event. As soon as we start this loop, it sort of captures an event, and it sends that event to the accelerometer, and it sends it to the altimeter. So now I start getting the information back from the devices I'm printed out. I'll go ahead and let you know I learned in iteration. I learned this wasn't the best way, so I'll go through what I changed here in a minute. But this is just my starting point, my first effort on it. I get the current temperature from the to calculate altitude, we have to know the temperature. So the first thing we have to do is ask the sensor for the temperature. So it gets the temperature, and just for my own peace of mind, it's printing it out to the serial display. And then there's a built-in function that will get the sensor reads pressure, but it's got a built-in function that will convert it to altitude. So we send it sea level pressure, what the pressure is for whatever it just read, and the temperature, and then it will do the calculations for us and produce an output in meters. And then I'm just delaying half a second before doing it again. And I'll save the drama plugging it up and showing it, because this didn't work real well. So I had to go try to figure out, well, why isn't it working well? And I basically just started trial and error, changing a few things here and there, and seeing where it led me. One trick of the trade sort of is to save and save often, and also don't just overwrite what you did. Save it as a unique name, especially when I got here. I wasn't really certain what was causing my problems. So I saved the original, I kept the original one, and then I started changing things. And this is a second attempt. It's basically the same, but what I learned is that in the previous version I was getting both sensors right here. I got the accelerometer and I got the BMP, and I asked both of them to return their event information one in a row. And what I learned is I couldn't do that. I needed to get one, process all that information from the one sensor, and then come down here and get the second sensor, because it ended up that the second sensor overwrote important information that the first sensor was giving me. So I changed my strategy a little bit, and this worked much better. Then what's still missing here is the writing it to the SD card. I have nothing in here that does this, but at least at this point, I'm getting something that works. It didn't appear to have problems, so now I can move on to the next little brick of construction, the block of code I need for the SD card logging. And this is now my third, well, it's number 2, but it's actually my third different version. That didn't work. The SD card pulls in this library here, SD library. Now I use the Adafruit tutorial. It's basically the same stuff I had before, except now I get into initializing the SD card. So the SD card uses pin 10, which is where the Arduino outputs the information to the SD card. And same as before with the sensors, it's looking for the SD card to be there. And if it can't find the card, it just stops, and that's all it does. If it does find the card, it gives me card initialized, and I jump back to testing my different sensors. Somewhere along the line, I found where I needed to speed up my data rate for the accelerometer. So I went to Adafruit, read the instructions, and say, oh, here's a command. And as I read their instructions, I think the next step up is 1200 hertz, but they had a warning that a lot of USB connections aren't going to function above 800. So I took it as high as I could go and still felt safe using it with the USB connection. So we get back to our main loop section, and so in the loop, the first thing I do now is I open a file called data log on the SD card, and I'm telling it I'm going to write data to it. Just because I called the command doesn't automatically mean that the file is there. These SD cards are kind of flaky. So I come in here and say, well, if I can sense that the data file is open, I'm going to start doing my sensing. So I get the accelerometer data, I get the data for this event, and I start writing the stuff to the data file. So I'm saying it's the same print, just instead of printing to the screen, I'm printing it to the SD card. So on the data file, print Millie's function returns the time since Arduino is powered up in milliseconds. So it gives me a timestamp down to the millisecond of when this data came in. In between everything, I'm putting a comma, which will help separate. I'm just basically packing as much information onto this file as I can. So whatever information I get, I write a comma and move on to the next thing. So I've stripped out from the previous version of the thing. I've stripped out all the stuff that made it easy to read for a human. I'm not labeling each thing. I just want to store the data. So my first column is going to be milliseconds. Then I want to store my X acceleration, my Y acceleration, my Z acceleration. And between each one, there's a comma, so I know when one set of data ends and another one begins. I go read my altimeters now. I do the same stuff. I figured, well, as long as I was getting the temperature, I'll go ahead and store the temperature. That may be interesting. So I write the temperature to the data file. Put another comma in there. And then I write the conversion to that altitude. And that's really the end of it. And what I discovered as I was doing this is that it takes time. As fast as that SD card is, it still takes time. So I've taken my delay down to just 5 milliseconds before I do the loop again. And then the other thing, I give it 5 milliseconds to finish writing. Then according to Adafruit, I need to close the file and wait for the loop to reopen it at the top. We'll talk a little bit more about that later. I'm not terribly happy with it, but I just ran out of time to do more troubleshooting. So let me go back to this and the camera version, and where I'm at now is I'm hooking up a USB. I'm hooked in and cross my fingers and hope nothing's changed. Upload the code to the Uno. It did something to change. Got to tell it I'd switched it to the Pro Mini, but I'm going to go back to the Uno for right now. It compiles the code and it uploads it. It's done uploading, and it's not working. I can tell that. But I can look at my serial monitor, and it gives me my warning message. So I don't have my card in there. So a little SD card and try it again. It's done uploading, and now it's moving on. So it gives me the initial setup from the ADXL. I do have 800 hertz data rate on it, and I did get it up to 16 Gs. And you can't really tell in the camera picture, but that little red light on the SD card is just blinking furiously. It's blinking every time it writes something to the card. So it appears to be working. I had loaded this up earlier, so I wouldn't waste your time looking at. Well, I had it loaded. It must have closed, but I can take the SD card and now I've got I called the file data log. I know that's really small. text, some kind of garbage, and then I get down and I'm actually getting what I expected. I get a millisecond, so 1,694 milliseconds. I was reading X, Y, and Z accelerations, 21.82 degrees Celsius, and an altitude of 251.27 meters, which is about right for where I am. I guess my house is about 900 feet above sea level or so, so that seems pretty reasonable to me. So as I'm looking at it, I'm getting results about every 100 milliseconds. Actually, here's every 50 milliseconds, almost 63 milliseconds. So that would be, what, 18 or 17 readings per second. So it's pretty good. One of the things I noticed looking at it, though, is it's not very consistent. Sometimes I get very, very, very fast readings. Other times there may be a couple of 100 milliseconds between readings, and it just keeps going. Another thing I noticed is every time I run the Arduino program, it doesn't erase my old data. It just, here I am at about 27 seconds of running, and that must have been when I pulled the plug and I tried something else, and now it starts over at just over a second after the Arduino's been powered on. So it gets kind of confusing to look at. You actually get multiple runs in the data file, but it's close, and it's definitely a step in the right direction. So I'm going to move back to hardware, and we have to now look at going from the big Arduino Uno to the Pro Mini. So that's roughly the size of the two of them. It's really amazing how small that's the Pro Mini right there. So it's just crazy how small these things get. On the Pro Mini, when you get to looking at it, you say, wait a minute, it's missing a couple of things. And one big, hugely important thing is the USB port. So it's the USB. How do you program it? That becomes more of a challenge. The Uno is nice, neat, and it just plugs right in. If you get to reading about it, you realize it's not just the actual port that's missing. On the Uno, there's a chip called the FTDI chip, which controls the USB communication. And to make the Pro Mini so small, they've stripped anything that wasn't absolutely essential off the chip to where it's just the main microcontroller, the AT Mega type chip. So this is where it got really fun for me. It got really challenging here. I got on Adafruit. I started Googling and researching, and that they sell adapters. I could go buy an adapter, and then I said, found information say, oh, we need an FTDI chip and the USB connection, and the Uno has all that on it, and you can actually hotwire an Uno to program the Mini. So that leads you down a whole nother path. And also, I didn't have time in a week to get the purchasing in, so this made a lot of sense just to hack the Uno. So to do this, what I had to do is, well, I followed the instructions, but you remove the big AT Mega microcontroller, which is this big main chip. That's what you're actually programming, and that's what does all the work. Most of the rest of the board of the Uno is simply there to support that big chip and to let you program it and do the other stuff. But this little guy right here, I'm not 100%, but I'm fairly certain that's the FTDI chip that we're missing on the Pro Mini. There's just nothing there. So I was lucky and had another Uno here. And you can see where I've taken the chip out. I followed the wiring hookup, the directions that they gave me, and what you have to do is you give it power, power and ground. Everything needs power and ground, and then you send it just like the I2C. You have a transmit. Well, it's not just like it, but it's similar. You're sending it data over the yellow and blue wires, which go into the pin 0 and 1, which are the transmit and receive. Trying to hook all this up, I got a little bit frustrated just trying to hold all the wires. So what I did is I soldered the wires to a little small board and put a little pin header on it. So now I put a pin header on the Pro Mini. So now if I need to hook it up, everything just plugs together like so. It's kind of ugly, but it works. So I'm on another breadboard. I've got the Pro Mini. I'm hooked up to the Uno to program it. This little red board here is a combined ADXL and BMP. It's all in one, so I just need the 2 wires going to it plus power. I've got to steal my data logger. So now this is basically my finished setup, just not all soldered together, as small as I can make it, but it's getting a lot smaller. This stuff up here is just extra components. I'll bring it up in a minute. And then the other one, the white cable I missed telling you about, is actually connects to the reset pin. The way these things program when you study it is when it starts, the very first thing before it sends the FTDI chip, before it sends a program, it hits the reset pin, and it knows the Uno or the Arduino knows to listen for a program for just a couple of milliseconds right after the reset pin is pressed. So it's a little trigger that says, hey, I may be sending you a program, so I had to wire up the reset pin. I did that on the white wire. There's these things called pinout diagrams, and they're your real friend. Volunteers put them together. This one guy in Italy, he does some great work. He puts it out there for everybody to use, and I know it's real small there. I had called it up. Well, here's his version of the Uno. But with these devices, the pins can do so much. You need it's another good roadmap. It's not just that the pin, pin 5 isn't just a digital pin with PWM. It also does have PWM. It's got other functions, and then all this communication. Well, like the I2C, it's these blue boxes, the SCL and SDA. And then earlier in the session today, we talked about the MISO and MOSI. So you have to track down what pins are which. So as I move from the Uno to the Pro Mini, I'm using these little maps to go find the stuff. And I'll be honest, it's just not, you get smaller and smaller, it's not easy to find these things because they don't have enough room to screen print what the pins do on the board. So you just have to use these pinouts, and but they really are great and make your life easy. So I've got everything together, and I brought up a couple little problems. I mentioned earlier that the data file just appends every time you run it rather than deleting it and starting up. I could delete it on the PC and then it starts a new file, but I probably want to add a little bit of code that will look for the file. If it's there, it'll delete it and start a new file. I'll be honest, I haven't had time to do that, but it's on sort of a punch list. The other thing I've noticed in doing this over and over again is the SD cards are flakier than I thought. They get corrupt very easy. So maybe about one time in 5, when I just stop it and I unplug it, I put it in my computer. There's no data file, there's just garbage, and I have to end up reformatting the card, doing it all over again. And most of the time it works, but 20% of the time to get a failure, that's a lot. And my own thinking is that it stopped in the middle of I just pulled the plug while it was writing some data, and it just got corrupted. So I'm thinking I need some way to gracefully stop the writing. So when the rocket goes up, it's taking measurements, it's writing, and then when it comes down to Earth, I want to maybe put a button or a switch on there that I can press and say, okay, it's all done, and stop writing, and then I can gracefully retrieve the data from it. Right? Maybe rather than a switch, there may be a way just in the program to for it to sense. You could incorporate some logic, like if I've been on for more than 5 minutes and my altitude is no longer changing, stop writing and just shut down. So there's a couple of ways of skinning that cat. We just need to figure out what works. I mentioned earlier that the data I'm getting isn't always very consistent. Sometimes it's 60 milliseconds between records, and sometimes it's more. And looking over my code, I go back and say, well, I think that one of the reasons is I'm writing every little thing, even the commas. I am writing a comma one by one as I write that data out there. So probably a better way to do that would maybe be to store 20 or 50 or 100 readings into an array that stays in the Arduino memory, and when that array is filled up, to write the entire array all at once. So I'm not just sitting here writing, and I'll at least cut down on the inconsistency, because the array will be in the Arduino's memory. It'll be almost instantaneous. I was looking at that, and they also make dedicated data loggers, which I kind of went the shoestring budget and bought the SD card, but they make something that's just about the same size, that its whole purpose-built function is capturing data. and what they actually are is another shrunken Arduino that it's preloaded with a program that all it does, it's just completely optimized to do the data logging. So to wrap up and whatnot, if anybody wants to ping me on the Google group or whatever, I'm more than welcome to get together and meet and do this in person and let you get hands-on with it. Greg had sent me a link on the Google group about battery packs. I've got 2 battery packs ordered. Sometime we have to build the rocket itself and then build the final payload package and solder it all up. And then whatever final software adjustments, whichever way we want to solve the various problems or make whatever adjustments, then just keep testing it and keep testing it. And I see Greg's got yeah. Once you sense that you're falling, turn off the data logging. Yeah, because your altitude would all of a sudden start decreasing. And then Greg's also identified the other big problem of where are we going to launch from, and haven't solved that problem yet. There's the Greg knows where I'm going to talk about, but there's a place down the road from us that used to be owned by the I guess the natural gas company. I don't know if they still own that or not, but it's a huge field. I was going to check into if it was possible to get permission to launch down there, right near, if you're in the area, it's near Hunt Meadows Elementary School. But we do need to find a big field with no trees and no power lines. So if anybody's got any ideas, I'd love to hear them. Something probably about the size of a full-size football field, or 2 or 3 at least. So any ideas, let me know. I think that's the end of it. But I can turn it back over to Beck, or if there's any questions. And I can turn it over to Beck, I think. Or Beck, if you can just take control, it's not letting me send it to you.
Beck? Beck? Hello?
Nope.
Beck?
Yep, I put him to sleep.
I'm still here. Hey everybody, if you can check out the Google groups, Colette's really made some progress on her on the LED panel, and if you guys can start getting those together, we'd really love to see some more people getting some code up there so that we can get that going of the next workshop. Yeah, she's doing awesome.
Yeah, that was good, really good work.
I know when we did the webinar that there was a few of you guys who were really excited about some of your messages that you wanted to do. So I know if Colette can do it, all of you can do it.
Can you hear me now?
Yeah.
Yep.
Okay. So I was actually talking, but my audio was cut out. So, but what I wanted to mention, you already mentioned Colette's LED lights that she's set up or programmed for. And I wanted to mention the workshops that are on November 9th and the 16th. And these are for getting a better understanding of everything we've done so far. So if there's something you're shaky on, post in the Google groups or email one of the instructors and tell them so that we know what to work on the day of the workshop. And we need the LED panel codes as well. And I believe that's the only two things I needed to announce at the end. Hello?
Okay.
I didn't know if my audio had cut out again.
No, you're good.
Okay.
Well, I think that's it then, right?
Yeah. Well, I'll see everyone on next Tuesday.
No, I think this is our last workshop, so I guess we'll see everybody on the 9th.
The 9th? Okay.
If anybody has any questions, though, post them up on the group, and then we'll all see what's going on, okay?
Bye.
Yep.
Oh, one more thing. Instructors, if you have anything that you need to order, let me know, because we're going to have to do another order soon. And we get discounts if we group things together that we need to buy.
Yeah. On that also, I got set up at Spark Fund with the 20% over $50, so there may be a little bit. I think Adafruit was $100 to get the discount, but
it's $250 to get a discount at Adafruit, and it's $50 at Spark Fund to get the 20%. But Adafruit is really it's a significant discount if we can get those minimums.
Yeah, well, and Adafruit a lot of times is easier to use. I found I like Spark Fund stuff, but Adafruit is more user friendly from just my own experience. But
yeah, and they got a quick turnaround too. So
yeah. Well, I know we have a few things that we need to get we need to get those the power switch cutoffs for the home automation project. But if there's anything else, just email me or email Melinda, and she'll forward it to me, and we'll get those together. Actually, just email me. It'd be easiest.
So do we have any specs on the home automation stuff? Do we know exactly what we're going to build out on that?
You need to talk to McKay about that.
Okay.
He has an idea. I think I'm going to be out of town for family stuff for the later half of the week, but I think he and I are going to try to work on that next week.
Okay, because I got a couple of pies. I got to get set up here.
Okay.
They're off, and I was gonna hook one of them up and start doing the home automation stuff with it. So.
Yeah, we'll just talk to McKay.
All right.
And if you get close to that Adafruit amount, let me know. I've got a couple of things on my own personal wish list I could bundle with you if.
Oh yeah, just totally send them over. We're definitely going to make that amount because we have to order a couple more of the LED boards and a few other things. So, and yeah, you know, we always have personal things that we tack on. So.
Yeah.
When are you going to order, Susan?
Probably sometime next week. I think Melinda and I have to go over the list together, but you guys need to get your. Just send me what you need in the next 2 or 3 days, and we'll sort it out.
Okay.
All right.
Okay. Bye.
All right. Thank you, Vaughan.
Okay. Talk to you later.
Great job. Thank you. And we'll see everybody November 9th at my office, 330 East Coffee Street. So I'll send the address and map out in the next couple of days.
Okay.
Yay.
All right. Sounds good.
All right. Thank you.
Thanks.